Welcome to House Talk, with videos that'll provide maintenance tips unique to Trilogy at Vistancia Homes. With your host, Doug Bowman.
Hello and welcome. This is my third video on the fire sprinkler system that's been installed in Trilogy Homes. If you've got a fire sprinkler system in your house, this is the video for you. The more I talk to Trilogy homeowners, the more issues seem to arise with this system. So today, I'm going to talk about the main components of the system, how the minerals found in our hard city water impacts them, and I'll show you how to do a full functional test of the system to ensure it'll work for you in the event of a real fire. If you've been maintaining your system all along, good for you, but if you haven't, you may be in for a big surprise. If you've gotten the City of Peoria quality report in the mail, you know that Trilogy's water comes from local area wells. While the city is working to supplement our water supply with alternate water sources, the fact remains that Trilogy's water has been and continues to be extremely hard. This is a problem for the city as well as Trilogy homeowners. This hard water is no friend to our piping or appliances or components. Items that are frequently used, like showers and water faucets, have a better chance of surviving because of the water softeners and the fact that they're regularly used and can flush particles away. But fire system components, especially ones with moving parts, are more subject to corrosion and failure because of their infrequent use. If you watched my video on fire pressure gauges, you've seen what mineral buildup can do. Corrosion built up in a pressure gauge may not indicate an accurate pressure reading. Corrosion buildup in a flow switch may not actuate the fire bell. But buildup in the system's check valve might prevent water from flowing to a sprinkler head and putting out a fire, and that could be devastating. So let's get started by briefly talking about the fire system, a few of the components, and how they work, and where you can find them. This sketch is about as simple as we can get to best understand the fire system. All of your water comes from the city water system, and it comes out of the ground on the side of your house. All of your water passes through a whole house shutoff valve, highlighted here. This valve is the closest to the ground. Closing this valve shuts off all the water to your house and your lot. Drinking water, irrigation, and your fire system. So it's not the valve you want to close for the summer while you're away, because you'll either come home to a burned down house or a yard full of dead plants. After water branches off to the drinking and irrigation systems, it flows uninterrupted to the fire piping system shown here. The first component is a check valve. A check valve simply allows water to flow through the pipe in one direction and not the other. There are several different types of check valves installed in Trilogy, but they all perform the same one-directional function. But my guess is that you didn't even know you had a check valve in your fire system, let alone where it's at or how to test it. It's one of the best kept secrets because you'd have to remove a piece of drywall just to find it. There's a good design. Next is a flow switch, which detects water through the system and energizes a fire bell on the outside of your house. It takes a pretty strong flow to actuate the bell, but don't worry, we're going to test it to make sure that it's working. Then there's the fire system pressure gauge that monitors the pressure on the fire system piping. These gauges are notorious for corroding. This is one of my favorites. No matter where it is, even on my workbench, it always reads 75 pounds. And looking at the corrosion, there's no wondering why. According to NFPA codes, these gauges should be replaced every 5 years. And if you find you have a smaller gauge that looks like this, it's probably still the original gauge and way overdue for replacement. Obviously, as part of our testing today, we're not going to spray water into your house through a sprinkler head, but that doesn't mean that there isn't some maintenance tips that you can do. Don't block sprinkler heads or obstruct the flow paths. Don't hang anything from them. Don't paint them or splatter paint on them, and certainly don't tamper with them or remove them. The last device in the system, other than the actual sprinkler heads, is the flushing valve. You may have seen this strange-looking valve and wondered what it is. Don't confuse it with a hose bib or garden hose valve. You'll see us using this flushing valve in just a few minutes during our testing. Now, as a homeowner, you're responsible for maintaining your fire system. That doesn't mean you have to repair it and make modifications to the system, but you can take simple steps to keep it in operating condition. It's like driving your car. If you detect a problem or your check engine light comes on, you take it to a certified auto technician to assess the problem and make the required repairs. The same applies to your fire system. You can test your system, but repairs should be done by an approved fire prevention contractor. The City of Peoria maintains a list of approved fire prevention contractors on their website, and I'll leave a reference to that list at the end of the video. Now let's get started with our testing. We're going to test all three of these components and be sure that they're operating correctly. I'm going to explain what we're testing, I'll perform the steps, and then tell you what the expected response is, and also the abnormal response. You don't have to write any of this down because when we're all done, you'll be able to download the same instructions I'm using to do the test. The link will be available in the first comment field of this video on YouTube. The first note on the instruction deals with communications. You should determine if your fire system is connected to a security service and notify them that a test is being performed. These are usually services that you have to pay extra for. Also, during the test, the house fire bell will be periodically ringing, so you may give your neighbor a heads up just so that he knows that the test is going on. The next section is just an inspection for leaks and visible corrosion. Find the fire riser panel in your garage. It should be on the inside wall of the garage, opposite where the water piping comes into the house. Remove the plastic cover with a flat blade screwdriver and inspect the enclosure. Piping and components should be dry and show no signs of leakage or corrosion. You may have to move some insulation around to see everything. That's okay. The red flow switch cover should be on tight, but if it's loose or removed, be careful because there's live wires inside for the bell circuit. As part of our testing, we're not going to have to go inside this cover. Now, several times today, you're going to hear me refer to the normal water pressure supplied by the City of Peoria. For 80 to 90% of Trilogy homeowners, the pressure supplied by the city is between 55 and 80 pounds. But for some homeowners, the actual pressure may be higher, much higher. I've seen actual pressures over 100 pounds. Many homeowners with high water pressure already know it because word gets around in these neighborhoods, and they often have pressure regulators already installed on their houses. Now for today's video, the pressure you see on a known good pressure gauge at your fire riser panel will be the actual city water pressure you are getting at your house, and this is the pressure you should see when you're done with each test and you're returning the system to normal. If this pressure reading is continuously above 80 pounds, you may want to install a pressure regulator to protect your household piping from long-term exposure to this condition. You can contact any plumbing company for this type of work. Now let's get into some real testing. We're going to test the pressure gauge to make sure that it's functional. We're going to isolate the water supply and bleed off the pressure. Step 1 is to write down the gauge reading. Don't worry about the actual number since we haven't tested it yet to see if it even works. Normally the gauge should read between 55 and 80 psi since that's the normal City of Peoria water pressure. Step 2 of our instructions is to fully close the whole house shutoff valve by turning it 90 degrees and isolating all water to the house. The valve handle may be hard to operate if it's not periodically been opened and closed. Step 3 of our instructions has us going over to the other side of the house where we're going to open the fire system flushing valve. We talked about what this valve looked like earlier. Now, slowly open the fire system flushing valve for about 10 seconds and let the pressure bleed down. Now, following step 4 of our instructions, close the flushing valve and observe the pressure gauge. It should be at or near 0. In step 5 now, we'll slowly open the whole house shutoff valve and repressurize the piping. The fire bell should not be ringing during this part either. Step 6, read the pressure gauge again. If the gauge is in good working condition, it should be reading the city water pressure, 55 to 80 pounds. Although, like I said earlier, some neighborhoods may be a little bit higher. If the gauge is off, wait a couple minutes and then reread it. If the gauge doesn't respond, it probably should be replaced. If at any point in time during today's testing you see a pressure gauge reading of 100 or 125 or even 150, that's because you probably opened up the supply valve way too quickly and you're seeing the effects of water hammer. If this happens to you, just redo this test, bleed off the pressure, and then for all future testing, slowly open up that house shutoff valve so you don't get that water hammer effect. You can learn more about replacing these pressure gauges by viewing my Trilogy House Talk video on YouTube called Fire System Pressure Gauges. Now we're going to move on to the next section of the instructions and start testing the check valve. Remember, we said the check valve blocks flow in one direction but allows flow in the other direction. In this section, we're going to test the ability to hold pressure in the backflow direction. And again, you don't have to write any of this down because the instructions will be available for download in the comments field of this YouTube video. We're going to start with a normal pressurized system. Then we're going to write down the starting pressure, which is usually between 55 and 80 pounds, close the whole house shutoff valve, and then bleed the pressure on the supply side and verify the check valve holds pressure, preventing the stale, stagnant water from bleeding back into our drinking water side. So here we go. Step 1, read the initial pressure. Step 2, fully shut the whole house shutoff valve. 3, open the hose faucet and relieve the water pressure, and then close it. Step 4, observe the fire pressure gauge and document the reading. If the check valve is operating correctly, pressure should not have changed from the initial reading. If the pressure degrades, this means that water is flowing backwards from the fire system into the lower pressure house piping. The check valve is most likely corroded and will need replacement by an approved fire prevention contractor. And step 5, slowly open the whole house supply valve and repressurize the piping. Now that we've completed testing the check valve in the backwards direction, we're going to check the check valve in the forward direction by doing a full flow test. This test will determine if your sprinklers will receive enough water to extinguish a fire if called upon to do so. If you do any of these tests that I've discussed today, this is the most important one. And you should perform this test every 90 days to keep the flow path flushed and clear of problems. This test uses 2 people, one to operate the flushing valve and the other one to watch the pressure gauge. But don't let that stop you from flushing the system by yourself. So let's get started. Step 1 of the instructions is to observe the pressure gauge and write down the reading. As we previously said, it should be the city water pressure somewhere between 55 and 80 pounds. Hopefully you've tested the pressure gauge previously to this test, or the results could be misleading. Step 2 is going to cause the bell to alarm if adequate flow is achieved. By fully opening the flushing valve, this should achieve the same flow as would an individual fire sprinkler in your house. Now slowly open the fire system flushing valve and flush the system piping for about 30 to 60 seconds. At the fire riser panel, the flow switch will detect the high flow, activating the fire bell, and the fire pressure gauge will lower to about half of the initial reading while flow is in progress. If there are no obstructions in the line, the flushing water flow will continuously be under significant pressure and velocity the whole time that flushing valve is open. When the time is expired, you can slowly close the flushing valve. The flow switch will reset, stopping the bell, and the pressure gauge will return to the initial reading. This is the results you want every time when you perform this test, and you should do it every 90 days to keep the system operating. If you are by yourself, walk over to the riser panel while flushing is in progress, and obviously you'll be able to hear the bell and read the gauge. What you've just seen was a successful test. Now we'll look at 2 types of abnormal test results. The first is when the flushing valve is opened. Water flows quickly at first, then diminishes as pressure drops. The flow then stabilizes at a reduced flow or trickle, followed by water just gravity draining out of the pipe. And at the fire riser panel, because the flow slows almost immediately, the fire bell never goes off, or it just goes off for a second, and the pressure gauge drops to near 0 pressure when the flushing valve is opened, indicating a block, most likely upstream at the check valve. The other abnormal test result is that the pressure gauge remains at full pressure when the flushing valve is opened, indicating a blockage downstream. If this diminished flow is what you get after performing this test, this is the flow that your sprinkler head will get in the event of a fire in your house. This is a significant defect and must be corrected by an approved fire prevention contractor as soon as possible. The current list of fire prevention contractors that have been approved by the City of Peoria is available on the city's website. The link here is shown below. Here's a great idea from one of our viewers. Once you get done with the test, just fold it up and put it on the back of the cover. Well, if you remember anything from this video, remember these. Download the functional test. The link is in the comments field. Do the full flow test every 90 days. Don't ignore the test results. And if you need repairs, hire an approved fire prevention contractor to come out and test the system and make those repairs. I know this has been a long video with a lot of new information, but thanks for hanging in there. If you have any questions about this video, feel free to grab my email address off of my Trilogy Life and send me a note. Feel free to subscribe to my House Talk channel, and don't forget to hit the like button.